Yellowstone's recent supereruption, the Yellowstone supervolcano in Wyoming, produced one of the planet's largest explosive eruptions, 640,000 years ago. This supereruption ejected 1,000 cubic kilometers of volcanic rock, covering a wide swath of the United States in up to 200 meters or 660 feet thick of ash and pyroclastic flow deposits. While this eruption is well known, it is not the only recent mega-eruption to occur at this second recent large eruption volcano. In fact, one other large volume explosive eruption has occurred since then, producing an eruption 50 times larger than the 1980 eruption of Mount St. Helens. What I am referring to is the West Thumb caldera. The West Thumb caldera. This caldera is currently located as part of the western section of the much larger Yellowstone Lake. Note how it seemingly has an oval-like shape to it. This marks the approximate rim of the West Thumb caldera, which measures 5.2 miles long and 4 miles wide. This caldera is approximately the same size as the crater Lake Caldera in Oregon, although it formed in an eruption about half as large. Unlike Crater Lake, there never was a towering stratovolcano at the site of the West Thumb caldera. However, exactly what this area looked like before its powerful eruption remains unknown, although there are several possibilities. Possibility 1 is that the area did not look fairly remarkable, as it consisted of thick forest with occasional small valleys and creeks. Possibility 2 is that the area was only lightly forested, as much of its original landmass was covered in white and orange-brown hues from abundant hydrothermal activity. What is known is that the area was partially covered by several thousand-year-old rhyolite lava flows. Regardless of what it originally looked like, by 175,000 years ago a very large volume of magma existed underneath the basin, measuring in the range of at least 25 cubic kilometers of material. As magma accumulated at depth, it began pushing the ground upwards on the order of dozens of feet. This uplift occurred in a similar manner to a mole digging a tunnel in a grass yard. After accumulating for more than 1,000 years, the area became primed for a major explosive eruption. This magma began heating the area's abundant groundwater, causing it over time to flash to steam. Since steam takes up a greater volume than the same mass of liquid water, it caused an immense amount of pressure to build. Finally, this pressure became too great, and a powerful explosion occurred. Caldera-forming eruption. This explosion shot boulders of rock in a several-kilometer radius, and alongside this produced large pyroclastic flows. The explosion was so big, in fact, that large volumes of magma began getting ejected high into the atmosphere, primarily through finely grained fragments and ash. As a plume of ash shot more than 40 kilometers into the atmosphere, large volumes of ash began to fall, causing the day to seemingly turn to night. This ash piled up, forming the Bluff Point Tuff. Then, due to the large amount of erupted material, a portion of the shallow magma chamber was becoming empty. This caused a large section of rock overlying it to collapse downwards, forming a massive caldera. In total, 50 cubic kilometers of volcanic rock was ejected in an eruption 11% larger than the 1883 eruption of Krakatoa. After the massive eruption occurred, small volumes of viscous rhyolite lava erupted onto the lake floor. Today, this area contains numerous underwater geysers which often punch small holes in the modern appearance overall icy lake in the winter. On its western shorelines several active hot springs can be found, along with large hydrothermal explosion craters that formed in the last 10,000 years. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank my new patron Christopher for supporting this channel.